Okay, so we are working on Module 3.2, Polynomial Functions. The chapter in the book that you can refer to as 5-2, and the problems I would like you to do are page 231, numbers 23 through 33 odd. Okay, so you'll be able to simplify polynomial expressions, which we reviewed a little bit in Module 3.1. Definitely review from Algebra 1. So you can go ahead and try 1 through 4. You should be able to do those independently. Remember that with subtraction, anything that is in a parentheses behind subtraction, all of those signs need to flip. Go ahead and hit pause, do those on your own, and then come back and check your work. Okay, so for number 1, I'm going to start with my largest degree, which would be 3. That'd be negative 3x to the third. I like to cross things out as I go. I think that simplifies things. I've got an x squared plus 5x squared. That gives me 6x squared. And I've got negative 6x plus 7x, gives me a total of 1x, or just x, and then 2 plus 5 is 7. Okay, number 2, let's go through. I need to flip all of these signs. So what I typically like to do, and I could actually do it right down here, is flip all of these signs, and then I'm going to write them right below the same degree terms in my first one. So this would turn to negative 2x to the cube, 2x to the third minus 2x squared plus 34x minus 30. So I don't need that any longer. So my final answer should be negative x to the third. You can put a 1 there if you need to. Plus 7x squared plus 57x minus 15. Okay, number 3. I've got an x to the fourth and a 7x to the fourth, so I've got 8x to the fourth. Remember that these do not change. This is in and out burger math. If I've got 8 double doubles here and 3 double doubles here, then I have 11 double doubles. That does not change to 4 by 4s, right? They're still double doubles. So that's going to change that. Negative x plus 5x is negative 4x minus 13, because that's not combining with anything. I think it's much easier to cross out as you go along. And so let's finish number 4. So I've got x to the 5th minus 2x to the 5th. It's going to give me negative x to the 5th. I only have a negative x cubed, so that's just going to stay by itself. Negative 6x plus 8x be positive 2x. And 1 minus 4 is negative 3. So, if-then statements, and I think some of you are thinking, well, we did if-then statements in geometry, but this doesn't really look the same as what we did in geometry. So what I want you to think about, and you can use a calculator for this if you need to, which is fine, might be helpful, because you're just trying to get the point across. So, if I plug in a number larger than 57, which of those statements would be true? And you're using inequalities, so you're using less than or greater than, or less than or equal to, greater than or equal to, or equal to. Maybe they come out equal to in some cases. Okay? So, I'm going to choose for my number bigger than 57, I'm going to use 60. That's my number that I'm going to use because it's nice and even. If I'm picking a number less than negative 57, I'm going to pick negative 60. It's the nearest 10, just going to round down. Okay, so if I take 60 to the 6th power, it's a huge number, 4.67 times 10 to the 10th, okay? If I take 6 to the 60th power, then I get an even bigger number, 4.89 times 10 to the 46th. That's a much larger number. Think about why that is. This you're taking a large number, but only multiplying it by itself 6 times. This, you're taking a fairly small number, but you're multiplying it by itself 60 times. That's a huge difference. So this side is definitely going to be worth more. On number 6, anything x to the 5 halves, that's between squaring it and raising it to the 3rd power. So if I do 60 and raise it to the 2.5 power, I get 27,885.5. Anything to the 0 power is what? That is 1. You should know that. So because that exponent is bigger, that's always going to be bigger if the base is positive. If base is positive, which we know that it is. Okay, here you should know which one's going to be bigger. If I raise something to the 8th power, is it going to be bigger than if I raise it to the 3rd power? Of course it's going to be larger. Okay, now now we're reversing everything. We're just taking negative of whatever our number is. So let's take negative 60. If I have negative, and think about what that's going to do to this, by the way. So if I have negative 60 raised to the 6th power, I'm going to get exactly that same answer, but negative. So I get negative 4 point, actually, would it be negative? Let's think about that. I have to put it in parentheses, negative 60, y to the x, 6. So I get exactly the same answer. Any even numbered exponent, those two negatives are going to cancel out. So if I have a negative times a negative 6 times, that gives me a positive, that gives me a positive, that gives me a positive. So my answer is exactly the same. So 4.67 times 10 to the 10th. However, if I raise this, anytime we have a negative exponent, we know that that means the reciprocal to the positive exponent. That is what that means. If I raise 6 to the negative 60, it means 1 over 6 to the 60th power. It means reciprocal. So let's see what happens there. So if we have 1/6 to the 60th, try that again. 1/6 to the 60th. I get, it's going to be a really small number, 2.05 times 10 to the negative 47. Because think about what that's doing. That fraction is getting smaller and smaller and smaller and smaller and smaller, but it is never hitting 0, because we know that's what our negative exponents do for us. So that is going to get smaller and smaller, but approaching 0, think about your exponential graphs. It approaches 0 but never touches 0, and goes all the way down. Okay? Number 9, we still know that x to the 0 power is 1. Doesn't matter what we put in there. But now we've got negative 60 to the 5 halves. Okay? So let's see what happens to that. Think about what you think it might do. I think it's going to be bigger than 1. So think about if we, oh, this is interesting. Now let's split this out. So if we, remember when we have fractional exponents, that is the same thing as negative 60 to the 5th and the square root of that. So if I take negative 60 to the 5th power, I get negative 77761, okay? And then I try to take the square root of that. Can I do that? I can't do that because I can't take take the square root of a negative number. So that is no solution. Okay? So 1 is bigger than a no solution. There's really, it's technically a no solution answer overall. And then again with this, what's going to happen to that negative 60? So negative 60 to the 3rd is going to result in a negative number because that's negative 60 times negative 60 times negative 60. So that's going to be a negative number. Because that is even and that is odd, that I know that that's going to be a bigger answer because this is always going to result in a positive answer, whereas this is going to result in a negative answer. This is negative 60 to the 3rd. This is negative 60 to the 8th. Because that is even, I know my answer is going to be positive. Because that is odd, I know my answer is going to be negative. So I know positive is always bigger than negative. Okay? Okay, so the next part of 3.2 is a large factoring view. Factoring is something that you did in Algebra 1. It is even more essential in Algebra 2. You did still use it in geometry. We're going to be doing a lot of factoring review in class. It is something I expect you to know. I expect you to know how to do it. I expect you to know how to solve equations based on it. It's not an optional entity in Algebra 2. So remember that for any trinomial, you have a first term, a middle term, and a last term. So we call this first, middle, last. Your first and last are always products. Your middle term is always a sum. The way you check that is you should be able to add up your factors to the middle, multiply your factors to the end. Okay? So, and you have to make sure that your signs work also. If you have your last term is a positive, the only way you can get there is a negative times a negative or positive times a positive. If your last term is negative, the only way you can get there is a positive and a negative, one of each sign, or a negative and a positive. Remember that because that's essential for factoring. Okay, so we're going to see that what number we can get to multiply to 15 that adds that to negative 8. So since that's positive, I know my only two choices are two negatives or two positives. That middle term tells me they have to be both negative. I can't add two positives together and get a negative. So the two numbers that multiply to 15 and add up to 8 are 5 and 3. You can always check this. Negative 5 plus negative 3 equals negative 8. Negative 5 times negative 3 equals 15. Those both check. Those have to be the factors for number 1. Number 2, 4 plus 4 is 8. 4 times 4 is 16. So I know those have to be the factors. Go ahead and try through number 5 on your own. Come back and check your work, please. Okay, so number 3. My factors of 10 are 1 and 10, 2 and 5. 2 and 5 don't add up to 7. And now that we're discussing negative signs, we're discussing difference. So I know because that's a negative 10, I need to have one positive, one negative. 10 times 1 gives me 10. But I know that I have to have the larger number being the negative because my middle term is negative. So check that again. Negative 10 plus 1 equals negative 9. Negative 10 times 1 equals negative 10. So those both check out. This typically is one that gets the wrong answer for quite a bit. If that's positive, my middle term is negative. I know that both of my answers must be negative. What multiplies to 6 that adds up to 5, that can only be 3 and 2. This problem gets confused with this problem quite a bit. Okay, so I want to give you a heads up on those types of problems. Get the screen a little clearer for you. Okay, so the difference is here, now my product is a negative, so I know I must have one positive, one negative. So now I'm looking for two factors of 6 that have a difference in between them of 5. Okay, so think about that really. If you are doing adding, you're thinking about a sum, subtraction, you're thinking about a difference. Okay? If this is negative, you know you have positive and a negative. That means I need to have a difference in between my factors of this number. So 6 minus 1 equals 5. 6 times negative 1 equals negative 6. Those both check out. Okay, so 6, 7, and 8. This is the more elaborate type of factoring. So when all of our coefficients so far, we have had a values of 1. If there's no number in front of the x squared, we know that that's always 1. Now all of a sudden we've got this guy going on. We're not quite sure what to do with that. So I'm going to show you two methods. You may even want to flip your paper over and do this on the back. 6x squared plus x, and we're going to do this in class as well, but I want you coming into class remembering how to do this. Okay? So there are two options. One is called BFDs, one is using X factor. So BFD says that you take your original equation, you multiply your A and C. Bring that over there, you're borrowing it. Okay? So that should give me x squared plus x minus 240. Okay? Now you're going to factor that. Now you're looking for factors that are pretty close together because you only have a difference of 1 in between. So let's think about what those could be. So I would have, let's think of things that are really close together. So 30 and 80, 60 and 40. What else could we have? Another way to find these is you divide one by the same number that you multiply the other by. So if I divide 40 by 2, I would get 20. 60 times 2. Oh, what did I do? Let's try that again. It's not going to be that much. Add an extra 0 on there. How about 30 and 8? 4 and 60. But I'm going the wrong direction because that gives me a difference of 22. That gives me a difference of 56. Those are all too big. So let me flip it the other way. How about 16 and 15? Okay, I doubled 8 and got 16, and I took half of 30, which gave me 15. Let's double check that 15 times 16 actually equals to 40. So that's 3, that gives us 90. Oh, sure does. Okay, so 15 times 16 is 240, and those do have a difference in between them of 1. So since that's positive, that's negative, I know I need to have one positive, one negative. My larger number is always going to go with the sign that's in the middle. So that's going to be x plus 16, x minus 15. Okay? Once you factor, this is important, once you factor that, now you need to give back that number that you borrowed away. Okay, so I divide each by 6. You have to simplify. Very important to simplify. So I would get x plus 8 over 3 and x minus 5 over 2. When we're solving and this is set equal to 0, this is the point where you would take the opposite of these answers. So if I were solving this, your answers would be 8 equals negative 8 thirds, 8 equals 5 halves. Those would be your solutions. Since you're just factoring, if they simplify down to a whole number, that's in fact that is going to be your factor. If you don't, if they still remain to be a fraction, you're going to take the denominator and swing it out to the front. So that'll be 3x plus 8 and 2x minus 5. That denominator swings right in front of your variable, right here. Okay? So BFDs. You know where that comes from. Now I'm going to do that same problem in x factor. It's up to you to choose which method makes sense to you. You must pick one. If you come up with your own method to do this, if you want to guess and check, fine with me, as long as you can factor. Okay? X factors, we're going to use exactly the same problem. 6x squared plus x minus 40. Going to draw your x. On the top of your line here, you're going to put your 6x, so your a value and the variable. Okay? Now, you are going to put your b value at the top, your ac value at the bottom. So our b value is 1. We add to get that. And our ac value is a product. So it's our product of our a and our c, which is negative 240. Now you're going to factor those. We already know the factors from up here. You're going to write your factors below there. You must simplify again. Neither one of these methods work without you simplifying. Not simplify. That's a whole different thing, but simplify. Okay? That's the cousin of superfly, but it's simplify. Okay, so now that's going to reduce to 3x over 8, and this reduces to 2x over negative 5. So our factors are 3x plus 8 and 2x minus 5. Okay? Using one of those two methods, I would like you to factor number 7 and 8, and then come back and check your work. Again, doesn't matter to me which method you use, as long as you can do one of them and do it well. So hit pause, work on number 7 and 8, and then come back and check your work. Okay, so let's do number 7. I'm going to do it both ways. I'll do BFDs first. So I'm going to rewrite that as x squared minus 6x plus 5, because I multiplied my 5 and my 1. Then I'm going to factor it. which is going to be x minus 5, x minus 1. Now I have to give back that 5. Okay, so I get x minus 1 and x minus 1/5. So the only thing that changes is that 5 needs to swing out in front of the x. So my factors are x minus 1 and 5x minus 1. Okay, again, reminder, how can you check to see that this is correct? Multiply them back together and check to see that you end up with this. It's a really necessary part of any math class. Whatever you do in college, if you're able to check your work, you should be doing that. You should be doing it in high school, you should be doing it on the job, wherever you are, you're going to want to check your answers. Okay, so if I multiply that out, again, you can use box, vertical, whatever. X minus 1, 5x minus 1. X squared minus 6x plus 1. That is indeed what we started with. So we know that we got that one right. Okay. Now let's do the same thing using x factor. Okay, so I'm going to put negative 6 up here, 5 down here, negative 5 and negative 1. I know I have to reduce this down. If you use x factor and this reduces to a 1, you need that 1 below there. So don't just leave it out like you normally would. You need that there. So those factors are x minus 1 and 5x minus 1. We already checked it. We already know that it works. Okay, number 8, I'm going to do the same thing. BFDs first. So that gives me x squared minus 11x minus 180. Okay? So I'm going to show you kind of a quicker way that you can figure out the factors, because that's a pretty big number. It has a lot of different factors. Before I said if you know 2 of the factors. So our equation is x squared minus 11x minus 180. Start with factors of this that you know. Okay? So you know you've got negative 10 and 18, or you've got 8, 10, and negative 18. Those don't have a difference in between them of negative 11. So I need to get that tighter. If you divide by 1, if you divide one of your numbers by a factor and multiply the other side by the same factor, you will in fact come out with the same product. So if I divide 18 by 2, I get 9. If I multiply negative 10 by 2, this is 18 divided by 2. This is negative 10 times 2. That multiplying by 2 and dividing by 2 cancel each other out. So your resulting product is the same, negative 20. Well, negative 20 plus 9 is negative 11. And that's what I need right here. So my factors are negative 20 plus 9. It's just a quicker way to factor, and we'll do a lot of that practice in class. Divide both sides by the number that you multiplied out. Remember to simplify. 2/3 and x plus 3/10. So my factors are 3x minus 2 and 10x plus 3. Okay, same problem using x factor. I'm going to put my negative 11 here. On my lines I've got 30x, and down here I've got negative 180. We already know the factors are going to be negative 20 and positive 9. That reduces to 10x and 3. This reduces to 3x and negative 2. So my factors are 3x minus 2 and 10x plus 3. Okay. We do have special products in factoring. If there is no, this is called the product of a sum and a difference. And what that means is, so think about what that means. It's a sum and a difference. It means you have one is positive and one is negative. Okay? The easy way to do these is ask anytime you see something that looks like this, there's something missing here that we had in all these other equations, and that would be a middle term, which means that our middle term has a value of 0. So you're asking yourself, what usually adds together that total 0. And that's usually opposite numbers, right? 5 minus 5, negative 6 plus 6. Those offset each other and cancel out. So whatever numbers are going here have to have a sum of 0, which means they have to be the opposite of one another. The easiest way to find that is you're going to always have square roots in these types of problems. Most 99% of the time, they're going to involve perfect squares. Excuse me, not square roots. Perfect squares. 81 is a perfect square. So all you need to do is take the square root of the front and the square root of the back. The square root of x squared is x. The square root of 81 is 9. Make sure that's true. 9 minus 9 equals 0. 9 times negative 9 equals negative 81. Those best check out. Okay? Even if there is a coefficient in the front, 9 is a perfect square. Square root of 9 is 3. X squared is a perfect square. 4 is a perfect square. I know my total in the middle has to be 0. So I know since I've got a negative 4, one is positive, one is negative. Take the square root of 9x squared, which would be 3x. Take the square root of 4, which would be 2. Done. If you need to check that, because you don't believe me that it could be that easy, check it. Okay? Negative 4, negative 6, 6x, and 9x squared. Those middle terms are always going to offset and cancel each other out. Okay? I've seen students make these problems really complicated, and they really don't need to be. Okay, so go ahead and do number 11 and 12, and then come back and check your answers. Okay, so for number 11, you should have gotten 4x plus 5y, 4x minus 5y. Number 12, you're saying, well, Miss B, that's not a squared, so how do I do that? But remember, using our fractional exponents, now that we know x, the square root of x to the 4th is the same as x to the 4th to the 1/2. Multiply powers together. What's half of 4? That is x squared. So the square root of x to the 4th is just x squared. I know I have to have a positive and a negative. The square root of 81 is 9. Again, you can check those if you want. X squared times x squared is x to the 4th. 9x squared minus 9x squared cancels each other out. And 9 times negative 9 is negative 81. You also have products when there is a middle term, but there's still a perfect square here in the end. Sometimes in the front as well. You can use the same theory, except the only difference is now you have the binomial, the square of a binomial, which means that your factor is going to be exactly the same. Use your square root method. We'll make all of these problems very simple for you. So what's the square root of 100? That would be 10. What's 10 plus 10? That's 20. That checks out. What's the square root of 49? I have a middle term of negative 14. Well, the square root of 49 is 7, but it's also negative 7. What's negative 7 plus negative 7? Negative 14. So what it really is that you have x squared plus, we're going to use the standard form equation. What you really have is you have a squared plus b plus c. You really have half of, the square root of 2 times the square root of c in your b value. You take the square root of that and double it. Okay? And that will be your factor. So the square root of the square root of 49 is 7 or negative 7, and I doubled it. Let's use that down here. What's the square root of 64? That's 8. Oh, but now we've got something going on over here. We have a 49x squared. Use your same method. What is the square root of 49x squared? Anytime you see a perfect square, that should be a red flag to you. And I am going to quiz you on the perfect squares, because that definitely makes factoring a lot easier when you have those just down. So square root of 49 is 7. Square root of x squared is x. Check those again to make sure. 7x times 7x is 49x squared. 8 times 7 is 56x times 2, because you've got 2. You've got one set there and one set there is 112x. And then 8 times 8 is 64. So those are the correct factors. You should be going back and multiplying every factor that you have and making sure that it multiplies back to the trinomial that you began with every single time. Okay? Last one, I'm going to take the square root of both. I have to look at that sign in the middle because I know that every square root has a positive and negative answer. This indicates to me it's going to be negative. Square root of 9x squared is 3x. Square root of 25 is 5. Again, go back and check. 3x times 3x is 9x squared. Negative 5 times 3x is negative 15x. You have two of those. Plus 25. Negative 15 and negative 15 is negative 30x. That's exactly what we started with, and check. The other way you can write 3x minus 5 times 3x minus 5 will be 3x minus 5 squared. You have those. That is also a correct written representation of that. Okay? Good. So we'll move on to graphing polynomials, and then you'll be done with section 3.2, module 3.2. Okay, this is in your book. It's chapter 7.2, problems 356, numbers 15 through 21 is what I would like you to do. For any of these, you should be able to graph these in polynomial. You should be able to graph a t-chart. If nothing else, you can plug in values for x and y. This is simply slope-intercept form. Remember that anytime you have g of x, f of x, any of that, that's equivalent to y. If it makes more sense to you to rewrite it as y equals x plus 5, please do it. This means you have a beginning point of 5, 1, 2, 3, 4, 5. You're going to go down 1 and over 1, or up 1 and over 1. This is linear. Okay. 16, x squared plus 5. Like I told you before, pick easy numbers. You don't need to pick really difficult numbers. Pick negative 1, 0, and 1. This, you should know, should be the shape of a parabola by the time you get done. Okay, if it's not the shape of a parabola, something's funky, something's up. Okay, so negative 1 squared is 1 plus 5 is 6. 0 squared is 0 plus 5 is 5. 1 squared is 1 plus 5 is 6. So you should have, all this did was shift. Now that you know how things shift in a log function, they shift exactly the same for any other kind of function. So this tells me I'm going to shift my whole mother graph up by 5. 1, 2, 3, 4, 5. Negative 1, 6, 1, 6. So my parabola is going to be up here. Okay. Okay, 17. What kind of graph is that? It's an exponential graph. So I'm probably going to have to change the units on this one a little bit, which is okay. So if I plug in negative 1, 0, and 1, 5 to the negative 1 is 1/5 plus 3, so that's 3 and 1/5. 5 to the 0 power is 1, plus 3 is 4. 5 to the first is 5, plus 3 is 8. So I would have negative 1, 3 and 1/5, so just a little bit up there. 0, 4, and 1/8 would be way up here somewhere. Okay. For this, for number 18, I would bump that out, 7x minus 28. Now obviously my graph is not going to support that, so I'm actually going to make each of these 7. 7, 14, 21, 28. Remember, you can make them whatever you want, right? As long as they're consistent. So why not make them whatever you want? So my beginning point is going to be at negative 28. I'm going to go up 7 and over 1. So my line is going to be on that really steep angle like that. That's still linear. This is exponential. Okay. All right, going to number 19. Again, we have, this is a quadratic equation. This is actually in vertex form. You don't necessarily need to multiply that whole thing out. Remembering, if this is at 0, our base mother graph for a parabola is there, right? That's an x, negative 1, 0, 1, and I get 1, 0, and 1. And that just means y equals x squared. That's our mother graph, is right here. So all that's saying is this is shifting everything to the right 4. We know that from logarithms. Whatever number makes this 0, so that's going to shift my starting point to the right 4, and then multiplying all of those results times 7. Okay, so I'm going to take all of my x values and subtract 4, and all of my y values I'm going to multiply by 7. So all of so it'll be -5. Oh, excuse me, I'm adding 4. It's always the opposite. Caught myself. So 4 minus 4 gives you 0. So -1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. It's shifting everything over here. Then all of these values I need to multiply by 7. So all it's doing is stretching it out. So I have 3, 1, 2, 3, 4, 5, 6, 7 will be up here. 4, 0, 5, 7 way up here. So I have a parabola, but it shifted it to the right, and it made it 7 times as narrow. That's what's going on there. Okay. This is an exponential equation a square root equation. So what I would do with this is pick values that make life easy. Okay, so if I'm going to plug in, like it'd be nice if I could get square root of 0, square root of 4, square root of 1. Make numbers that make that happen. Okay, so what am I going to put in here to get 0? I'm going to put in 4. 4 minus 4 is 0. Square root of 0 is 0. Times 7 gives me 0. If I want this to be 4, 8 minus 4 gives me 4. Square root of 4 is 2. Times 7 is 14. It's kind of a big number. I don't even know if I like it that much. We'll see. What would give me 1 here? Would give me an input of 5. 5 minus 4 is 1. Square root of 1 is 1. Times 7 is 7. Okay, let's try a negative number. If I put in there, let's see. I don't really want to put any negative numbers in there, do I? Because I can't take the square root of a negative number, so that's not going to help. What about, what would give us, let's just go with those. Okay, 4, 0. 8, 14. Let's see, 5, 7 is going to be way up here, right? And then 8, 14 is going to be way up here. Like that. It's kind of off the chart, but okay. Okay. Now, with 21, we're going to do the same idea that we did with this, because that is a linear function, but it's shifting everything over. So we can multiply this out. Probably be easier. So you have 1/2 x minus 3/2 minus 2. So that would simplify to y equals 1/2 x minus 7/2. So we're going to begin at 1, 2, 3. So it's -7.5. And then we're going to go up 1 over 2. Up 1 over 2. Okay. That is a linear function. It's going to be just that simple. Here we have something similar, but what it's doing is it's taking our base. Remember with quadratic, we can start with our mother graph, of which we had -1, 1, 0, 0, and 1, 1. Now that tells us that that's going to take that result. Let's see what it does. It's going to shift everything, all of my x values, increase them by 3. Okay, let's do it one at a time. So if we just took these answers and we added 3 to my x values, right? So my x values would be I'm going to add 3 to this. So -1 plus 3 is 2, 0 plus 3 is 3, and 4. These aren't changing yet. Now I'm going to take those numbers. Sorry. Now I'm going to take those numbers and multiply them by 1/2. So I have 2, 3, and 4. and I'm going to take 2, 3, and 4, multiply them by a half. So I'd have 1, 3 halves, and 2. Okay? These still haven't changed. I haven't done anything to them. Only now am I going to take those same answers and now decrease my y values by 2. So now my y values are going to, or excuse me, my x values are going to stay the same. And now my y values are going to decrease by 2. So 1 minus 2 is negative 1. 0 minus 2 is negative 2. 1 minus 2 is negative 1. So what I end up graphing is 1, negative 1. 3 halves, negative 2. And 2, negative 1. So my parabola got a little bit skinnier, and it shifted over 3 and down 2. But what really happened is a shift of 2 happened. Instead of shifting it over 3, that's getting multiplied by that. So it's shifting over 3 halves. Okay? Last one, the mother graph for an absolute value equation really looks similar to parabolas. Use your negative 1, 0, and 1 again. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. So it looks the same, but instead of it being bendy, they are just straight angles like that. Okay? But your shift is the same. This is going to shift it to the right 3 and down 2. Exactly the same shifts that we dealt with in logarithms. So once you understand how these functions shift, you can move any of these functions. So I'm going to take my beginning points. So tell me the points I had on that line. I had negative 1, 1, 0, 0, and 1, 1. So all of these points, I'm going to add 3, negative 2. 3, negative 2, 3, negative 2. I'm going to add those to all of my points. So negative 1 plus 3 is 2. 1 minus 2 is negative 1. That's going to be my new point that I graph. 0 plus 3 is 3. 0 minus 2 is negative 2. 1 plus 3 is 4. 1 minus 2 is negative 1. These are now my points that I'm going to graph. So I have 2, negative 1, 3, negative 2, and 4, negative 1. The way you can double check that, I should have shifted everything to the right 3 and down 2. Well, here's 1, 1, 2, 3, and down 2. So that's done correctly. Okay, so that is Module 3.2. Anything that you have questions on, you need to ask. You definitely need to do the homework. It will help you. Repetition is your best friend when it comes to polynomials, and factoring especially, factoring and graphing. And that's it for today. Thanks.